All right, hi everybody. This is video number 11, and this is chapter 3, section 4. And this is all about solving quadratics by completing the square. However, before we can do that, you need to be aware of a couple of other processes. So, the goal of this, I'm going to tell you what that is. The goal is to, our first goal, turn any quadratic into a perfect square trinomial so that it can be factored into a perfect square binomial. All right, so let's see how that's going to work. And there are some specific things that have to happen in your trinomial in order for it to be a perfect square trinomial. So if we are given x squared minus 10x plus 25, this is a perfect square trinomial. How do you know? So a perfect square trinomial, and we're going to start with this and then end up going backwards, has the following conditions. 1, the a value must equal 1. 2, if you take the root of c and multiply it by 2, so 2 times the root of the c value, that has to equal the b value. That must also be true. And so if we take a look at this guy, well, the root of 25, that's c, is 5. And if we multiply it by 2, that's 10. And this is our b value. So this is c. The root of c is 5. We multiply it by 2, and that's that. So when these things are true, so this is a perfect square trinomial. If you have a perfect square trinomial, you can now factor the perfect square trinomial into a binomial squared, and that binomial is the root of the ax squared term. Oh, I'm going to need more room in there. The root of the ax squared term, and then plus or minus, and this comes from the b, the root of the c term, quantity squared. Okay, so if we take a look at the one right up above, I'm going to move it up, but then bring it back so you can see it. All right, I'm going to factor into the root of the ax squared term. Well, the root of the ax squared term is just the root of x squared, which is x. That's going to go in here. So that's the root of this is going into the left-hand side. The root of this goes in the right-hand side. And then the sign off the b term goes in the middle. Quantity squared. What that means, just to lay this out for you, so this is the factor. This is our goal for now. But here's how this actually works. This means there's 2 of these, right? So x minus 5 times x minus 5. And if I FOIL, then I get x squared minus 5x minus 5x plus 25, x squared minus 10x plus 25. And this is what I started with. That is a perfect square trinomial. Okay, so I want to try this with a couple others just so that you get comfortable with this and see where we're going to go with it. let's see, if we have x squared plus 12x plus 36, is it a perfect square trinomial? Well, in order for that to happen, we need to know that a equals 1, and that's true. And then we need to know that 2 times the root of 36 equals 12. Does that actually happen? Well, 2 times 6 is 12, so that happens. And this is that 2 times the root of c has to equal b, right? That's what this actually is. And so this is a perfect square trinomial, so we can factor it into the root of ax squared plus or minus the root of c, quantity squared. Well, the root of ax squared is the root of x squared. And then I want the sign from the b term, excuse me, and then the root of 36 squared. And you're going to simplify this to make it be x plus 6 quantity squared. And you could take that right from up here. The root of that plus the root of that. Okay? Let's do one more. If you have x squared minus 22 plus 121. All right, I'm just going to kind of take a look at it. A is 1. The perfect square of this is 11, so the root of c is 11. 2 times 11 is 22, and that's our b term. Oh, there should be an x on there. That's our b term, so we can factor into the root of that, sine from b, and the root of that, quantity squared. Okay, so given the perfect square trinomial in blue, factor it into what's in green. Now, the beginning problems in varsity look like this. They're going to give you something like a squared minus 30a plus a blank. And you need to find the value that makes this a perfect square trinomial. And what you're going to do that is always going to be 1/2 of the b value, and then you're going to square it, always, in order to find this new c value. So this equals the new c, or I'm going to refer to it as the blank, because we're going to be putting blanks into our equation. Okay, so the blank is going to be 1/2 b and square it. Well, in this problem, 1/2 of 30 is 15, and 15 squared is 225, and that number would go right up here. So that's your perfect square trinomial, and now you're going to factor into the perfect square binomial. So it's the root of the a squared term, which is a, the sign off the b term, which is the minus, and the root of the c term, which is 15. And don't forget to square that quantity, and that would be the squared form of that. Okay? So there's a couple of questions in varsity that look just like that. They left the blank for the C. You have to fill it out and then go from there. So let's do just one more before we actually go learn how to complete the square. So this one, let's say you have x squared plus 3/2 x plus a blank. All right, well, you're going to take 1/2 of b and square it. Well, 1/2 of 3/2. Remember, when you multiply fractions, you multiply straight across. So this is just 3/4. And then you're going to square it. And that means you have 3 squared over 4 squared. Just square the top, square the bottom. So you have 9/16. And that would go right in there. And then when you factor this trinomial, you get the root of the ax squared term, which is x, the sign off the b, and then the root of c, which is 3/4. And you square it. So this is the factored form perfect square binomial. That's what this is. That factors from the perfect square trinomial at the top. Now we're going to use this whole idea. So this is the beginning. Now we're going to use this whole idea to solve quadratics by completing the square. And the reason we learn to do this, well, A, it can be very simple and easy, but B, if we were to go and do conic sections later, a whole big chapter in Algebra 3, and I don't think we're going to get there, but if we did them, there is a lot of places where you need to know how to complete the square to actually go forward. All right, so this is completing the square. And you're going to need to make a list of steps, and they're pretty long. There's 6 steps. I'm going to actually write them out and then split my screen so we can see them on one screen and do the work on the other. So let's just make a list of steps here. So step 1 is going to be make sure that your problem is in standard form. So be sure the problem is in ax squared plus bx plus c equals 0 form, which is standard form, before you do anything. Okay, that's got to be step 1. Number 2, the a must equal 1. So if it doesn't, then divide every term by the a value and simplify or reduce. Okay, I'm purposely going to pick some problems where a is not 1 right off the bat so that you get in the habit of doing that. All right, and then step 3 is going to be to move the c value, move the original, we'll call it the original c value, to the right side of the equation. And replace it with a blank. Now, you're going to see that we're going to throw a new value in on the left-hand side of the equation. So we also need to add a blank on the right-hand side so that we keep this equation balanced. Okay, so step 4, we are going to fill in the blanks with 1/2 of b quantity squared. All right, then the next step, 5, we are going to, your left side, the left side is now a perfect square trinomial. So you're going to factor that into a perfect square binomial. You know, what the previous, 15 minutes of this lecture entailed, into a perfect square binomial. And on the right side, just do the math. You're going to have stuff to add together. I know, without actually seeing what's happening here, it doesn't make a lot of sense, but it'll get there. And then step 6 is to solve for x. by taking, oops, the root of each side and simplifying. And sometimes it's this very last step, the simplifying, that can be the hardest part. It's not the rest of it if you understand what's happening. So we're going to do a couple of examples. I'm going to go to a 2-page view here. Dual page, we're going to turn that on. We're going to add a page. And then I'm going to pin this page so that it doesn't go anywhere. That might take me a second. View. How do I pin the page? Here we go. Oh, poop. Okay, so here's the first problem that we're going to do. And I'm expecting that you're just going to continue on down your page, but I want you to see all of these steps as we go. So I'm trying to get that little block off of there. All right, so we're going to go to this page. And the problem we're going to start with is solve 2x squared minus 4x minus 96 equals 0 by completing the square. All right, well, let's take a look at the page on the left. The first purple step. Be sure the problem's in ax squared plus bx plus c equals 0, standard form, which it is. So we're going to go to step 2, the green step. The a value must equal 1. Well, that's this guy, and it definitely is not 1. So it said, if it does not, then divide every term by the a value and reduce. So we're going to divide by 2, divide by 2, divide by 2. Every term, even the 0, that's kind of unnecessary, but just so you see it happening. And for step 2 now, the 2's cancel. We get x squared minus 2x minus 48 equals 0. Okay, so that's the green step. I'm going to try to match up colors, right, so that these things make sense. Step 3, move the original c value, this guy, to the other side. Well, when we move it, what's going to happen to its sign? Well, it's going to change. So we have x squared minus 2x, and we're going to put a blank on the right and left side of the equation where the c was, and it's always going to be plus a blank. So we move the 48, it becomes positive. We add another blank in, right? Because if I'm changing the left side, I have to change the right side by the same value. Now we're going to fill in the blanks with 1/2 of b. Well, 1/2 of b is 1. Squared is still 1, and that's going to go into both blanks. Okay. Again, I want to just remind you that you can always hit rewind, back up, re-listen. If you don't understand what's happening, you can go back through these. And in the next couple that I do, after you kind of know what's going on, I would highly recommend that you pause when I say I'm going to go do a step, and you go do it first and see if you can predict what's going to happen. That way you know that you're on the right track. All right, so let's go to, we're at step 5, black. The left side is now a perfect square trinomial. And by that, let me just highlight. The left side is now a perfect square trinomial. That's this guy. Okay, what we filled in the blank, that is our perfect square trinomial. So we're going to factor that into the perfect square binomial, which you already learned. So we're going to factor into the root of that, which is x, the sign from the b term, and the root of that. Quantity squared. All right, we factored the left side, and then do the math on the right side. Well, that would be this. So 48 plus 1 is 49. And now, step 6. Solve for x by taking the root of each side, right? We have a square. The opposite of square is to root. So the square and the root cancel each other. Don't forget that when you take the root of a number, it's a plus or minus, because you don't know if you have 7 times 7 is 49. Oh, geez. Why is this not writing? Pen. Need a pen. Don't have a pen. 7 times 7 is 49, or negative 7 times... Negative 7 is positive 49. I try to write little and it just doesn't work. So you need to make sure that you're dealing with both possibilities. So don't forget the plus and minus in here. All right, now in order to solve, you've got to move this guy. And I want you to always put whatever is here on the left side. When you move it, put it in front of the plus or minus sign. So we're going to add a 1. So we're going to have x equals positive 1 plus or minus 7. And if these are whole numbers, then you're going to go 1 plus 7 and 1 minus 7. 1 plus 7 is 8, and 1 minus 7 is negative 6. And those are our two answers to that question. So x equals 8 and x equals negative 6. And, whoops, I don't know what just happened there. If you, where did my pinned page go? That was super weird. Hold on, I got to find that. Okay, so we go here. All right, there we go. I don't know what happened there. Sorry. X equals negative 6. If you were to go and plug either one of these answers into the original equation, they would satisfy those equations. Okay? Now, these get more and more difficult when these are not whole numbers. If the root of 49, if this isn't a perfect square, these can get a little bit gross. So we're going to practice a couple that get gross. The next one will also be a perfect square, just so you know, just so you can see how this is going to work. All right, so let's re-walk through these steps. We're going to solve 4x squared plus 16x minus 12 equals 8. All right, purple step, number 1. Be sure the problem's in ax squared plus bx plus c equals 0. Well, it is not. So we need to subtract an 8 and subtract an 8. So that gives us 4x squared plus 16x minus 20 equals 0. Step 1 is now satisfied. Step 2, the green. A must equal 1. Well, it doesn't, so we're going to divide by a and make it 1. And that gives us x squared plus 4x minus 5 equals 0. Now we're going to move the c value to the other side and replace it with a blank. 5 becomes positive when it goes over there. Now we're going to number 4, the red step on the other side. Fill in both blanks with 1/2 of b squared. Well, 1/2 of 4 is 2. Squared is 4. And that goes in both of those blanks. Okay, recall that the whole purpose of this is to turn this into a perfect square trinomial, which you have now done. So we're going to factor that into, oops, I want a black pen. The root of that is x. The sign from the b term is plus. The root of the blank is 2. Quantity squared equals 9. And then we're going to solve for x. So we're going to solve by taking the root and taking the root. Those cancel. Plus or minus 3 is the root of 9. We're going to move that 2 over and put it here. So x equals negative 2 plus or minus 3. Negative 2 plus 3 is 1. That's one answer. And negative 2 minus 3 is negative 5. And that's the other answer. Okay? So these are pretty straightforward when you don't have fractions in them and you have perfect squares. We're going to do 2 more examples. One where you're going to have not a perfect square and one where you're going to have some fractions, just so you know how to handle those. Okay? The process is going to stay the same. So the numbers will change a little bit. So we're going to solve 2x squared plus 20x minus 65 equals 9. Step 1, purple. Be sure the problem's in standard form. It's not. We need to move this 9 to the other side by subtraction. So we now have 2x squared plus 20x minus 74 equals 0. Next, green step. We're going to make sure a is 1. It's not. So we're going to divide every term by a and simplify. So we get x squared plus 10x minus 37 equals 0. The next step, the blue one, move the original c value to the other side of the equation. So we're going to do that by changing its sign. So we're going to have a plus 37 over there. and replace it with a blank. So 10x squared plus 10x plus a blank equals positive 37 plus another blank. Your easy step, fill in the blanks with 1/2 of b and square it. Well, 1/2 of 10 is 5, and 5 squared is 25. And those go in both the blanks. Okay, this is now your perfect square trinomial. We're going to factor that by taking the root of the a squared term, which is x, the sign off the b, which is plus, the root of c, which is 5. Don't forget to square the binomial. And then just do the math on the other side. And when you take 37 plus 25, you get 62. All right, now we're going to do step 6, solve for x by taking the root of each side and simplifying. So we're going to take the root, the root and the square cancel each other. So we have x plus 5. And the root of 62 doesn't simplify because this is the root of 2 and the root of 31. Both of those are prime. So you're just going to keep plus or minus the root of 62. Now, side note, if that did factor, let's say if you had the root of 20, you can break that down into a 2 radical 5. So I would expect that you would have plus or minus 2 rad 5, not plus or minus the root of 20. You need to simplify any simplifiable roots. Okay? Then we're going to move the constant, this guy, by changing its sign and putting it in front of your plus or minus sign. So this is going to be x equals negative 5 plus or minus the root of 62. And these are your two answers here. One is negative 5 plus the root of 62. The other is negative 5 minus the root of 62. You can just block off both. You may see both in varsity, meaning these two here. You might see this in varsity. They might have a plus or minus. I'm not sure, but that's both of your answers. All right, ready to do one with fractions? This will be fun. It might also have, well, now I didn't do one with imaginary numbers, but they can have those too. So just think outside the box and do what you know how to do if that actually happens. So this is our last example here. We're going to solve 3x squared minus 4x plus 3 equals 0. All right, step 1, make sure it's in standard form. It is, so we're good. Step 2, make sure the a is 1. It's not, so we're going to divide everything by 3, and that gives us x squared minus 4/3 x plus 1 equals 0. Don't panic because that's a fraction. That's the whole point of this problem, so you know how to do these. Now, the next step, step 3. Move the current c to the other side and replace it with a blank. So we're going to have x squared minus 4/3 x plus a blank. The 1's going to become negative when it goes to the other side, plus a blank. All right, well, we know that our blank is 1/2 of our b term squared. Well, remember when you multiply fractions that you're going to multiply straight across, top and bottom. So this is going to give us 4/6. You should reduce that to 2/3. And when you square a fraction, you just square the top and square the bottom. So you get 4/9. And so that number, that 4/9 is going to go into both blanks. Okay? Now, this is still a perfect square trinomial. You might not like it because it's got fractions in it, but it is still a perfect square trinomial. So we're still going to factor. The root of this term is x. The root of this term means you take the root of the top, root of the bottom. So that's 2/3. And we still take the sign off the b term and we square it. So the process is identical, even though you may not like what it looks like. And then you can do fractions in your calculator. So -1 plus 4/9 ends up giving you 1/3, actually. All right. Now some knowledge of your roots and rationalizing denominators is going to have to come into play. Step 6, green. Solve for x by taking the root of each side. The root of that, root cancels the square, and the root of that. So I have x minus 2/3 equals plus and minus 1 over rad 3, right? This is the root of 1 over the root of 3. can't simplify the root of 3, you do need to rationalize. Which means you're going to multiply by rad 3 over rad 3, which means your new right side is plus or minus rad 3 over 3. So I now have this. Okay, now we're going to move this guy and put him in front of the plus or minus sign. So we now have x equals a positive 2/3 plus or minus rad 3 over 3. And while this is an answer, let me show you what the more acceptable answer is mathematically. 2 plus or minus rad 3 all over 3. So I want you to remember, if you have a over b plus c over b, it equals one fraction, a plus c over b, right? As long as your denominators are the same, you just add your numerators and keep your denominator. I want you to do this and make it look like one fraction. Now, here's where an issue, this is the answer to this problem, but here's where an issue might come in. If you get this, let's say you have x equals 2 plus or minus rad 5 over 3. Well, you now need to create a common denominator. And so your 2 is really over 1. Your common denominator is going to be 3, so you got to multiply the top and bottom. So your equivalent fractions become 6 over 3, right? That's 2, plus or minus rad 5 over 3, and now combine. Okay, so this is x equals 6 plus or minus rad 5 all over 3. So that didn't happen in the problem that we had, but it may very well happen, and you should know what to do if that does happen. The other thing that can happen in these is that when you get, let's actually go back to another problem. When you get to here, this number could be negative, right? If this was a negative 62, make sure that you take that I out when you reduce, right? That could happen, that you end up with that. So these could be imaginary numbers where you have no x-intercepts if you actually graph these things. So that's a possibility. I don't want you to think that that can't happen. All right, well, that wraps up 3.4. So there's, I'm sure, I don't recall, but I'm fairly sure there's a varsity and a worksheet on these to help you learn how to complete the square appropriately. All right, well, toodaloo for now.